Friends, welcome to my YouTube channel. Dhanesh here. See, we were discussing with natural language processing (NLP). This is the 13th video on NLP. We are going to discuss on TF-IDF algorithm. In the last video, we were discussing with feature extraction and bag of words. See, in this video, I am going to discuss about TF-IDF algorithm. This is a quick introduction to NLP. We already discussed natural language processing. NLP is NLU plus NLG. NLU, natural language understanding, and NLG is natural language generation. NLU is responsible for understanding the content, and NLG is responsible for generating the content. This is a pictorial representation of the components of NLP. We already discussed. These are all the steps to be followed while building an NLP pipeline. We have already discussed all the steps: sentence segmentation, word tokenization, stemming, lemmatization, identifying stop words, dependency parsing, POS tags, named entity recognition, and chunking. See, we have separate videos for all these steps. So we already discussed. See, before getting into the TF-IDF algorithm, we need to follow these steps to execute the TF-IDF algorithm. This is the life cycle of an NLP project. Even we have a separate video on the life cycle of an NLP project. In this, you can see feature engineering. This TF-IDF algorithm is coming under feature engineering. This is the pictorial representation of NLP life cycle. So we have a separate video for NLP life cycle as well. You can see here TF-IDF, it's coming under feature engineering. See, let's discuss something important about feature engineering. See, when we deal with an NLP problem, our input is text. We have to convert those inputted text into something that our algorithms can understand. In general, we can categorize the features into two big categories. One category is meta features, such as word counts, stop word counts, punctuation counts, the length of characters, the language of text, and many more. Another big type of feature are text-based features. Here we discussed about tokenization. Tokenization we implemented using NLTK and even TensorFlow and Keras. We have separate videos for that. Stemming we have done with NLTK. Lemmatization, NLTK library we used for implementation. POS tagging we have implemented through NLTK. And see, these process are part of the text-based features. Different feature extraction methods when we discuss. This is the bag of words model, bag of n-grams model, TF-IDF model, word to word embedding. These are all the different feature extraction techniques we use. We have already discussed about bag of words and bag of n-grams model. Now we are going to discuss about the TF-IDF model. You can see it, how it is. See, this is the steps we follow you during feature extraction. The input, it is the text. You will clean the text, then you will tokenize. You will apply, word tokenization, lemmatization, stemming. Then you will build the vocabulary. Then you will generate vectors. These vectors are the input to the machine learning algorithm. This is very important. So this is the, pictorial representation of the feature extraction. You can easily understand this. Then what is this TF-IDF algorithm? We call it as word frequency algorithm as well. TF-IDF algorithm or word frequency algorithm. TF-IDF stands for term frequency inverse document frequency. This is a technique to quantify a word in documents, we generally compute a weight to each word which signifies the importance of the word in the document and corpus. This method is widely used. It is a widely used technique in information retrieval and text mining. And it is easy for us to understand the sentence as we know the semantics of the words and the sentence. The computer can understand any data only in the form of numerical value. So for this reason, we vectorize all of the text so that the computer can understand the text better. Now we will see these are all the terms this is the math of TF-IDF. See, TF-IDF, that is equal to, this is the equation you need to understand. TF-IDF is equal to term frequency into inverse document frequency. Term frequency is TF. I will tell you what is term frequency. We will be discussing what is inverse document frequency. IDF we are going to discuss. See, T, the letters we are using, T means term or a word, term or word. D means document or set of words. N means count of corpus, and corpus means the total document set. These are all the letters we use in the coming discussion. So the TF-IDF, the formula for TF-IDF is the term frequency into inverse document frequency, IDF. Let's get into try to understand term frequency. This is very simple. See, this measures the frequency of a word in a document. Term frequency measures the frequency of a word in a document. When we are vectorizing the documents, we check for each word's count. In worst case, if the terms doesn't exist in the document, then that particular TF value will be 0, and in other extreme case, if all the words in the document are same, then it will be 1. The final value of the normalized TF value will be in the range of 0 to 1. Now, term frequency TF is how often a word appears. See, in the simplest way we can define term frequency TF is how often a word appears in a document divided by how many words there are. For example, the formula for term frequency is number of times term or word T appears in the document, the whole divided by total number of terms in the document. For example, you have a document with 1,000 words in that document, and you want to find out the term frequency of the word, pen. You want to find out the term frequency of the word pen. So pen is repeated how many times in the document? Let us assume that it is repeated 10 times. If it is repeated 10 times, how do you calculate? It is 10 divided by 1,000. It is 10 divided by 1,000 is the answer. See, what is 10 here? For example, you are calculating the term frequency of the word pen. This is the word PEN. The term frequency of the word pen in the document. The word pen repeats 10 times. Number of times the word pen comes in the document is 10. The total number of terms in the document is 1,000. Then what is the term frequency? It is 1. This is equal to 1 by 100. This is the way you calculate it. This is term frequency. Now I will discuss document frequency. This is rarely you use, and I will explain what is document frequency as well. This measures the importance of document in whole set of corpus. This is very similar to the term frequency. The only difference is that TF is frequency counter for a term T in a document D, whereas DF, document frequency, is the count of occurrence of term T in the document set N. That means DF is the number of documents in which the word is present. So that is another term you will use in this algorithm, that is document frequency. See, another important point, this is really important, you need to understand here is the inverse document frequency. See, what is inverse document frequency? See, we already discussed term frequency is how common a word is, how common the word appears in a document, that is term frequency. Inverse document frequency, IDF, is how unique or rare a word is, that is inverse document frequency. The equation for inverse document frequency is logarithm of total number of documents, the whole divided by number of documents with term T in it. That is the formula. See, you have the log of total number of documents. See, logarithm of, it's a log to the base e, it is not underscore, it is log to the, it is the formula is log to the base e. Here, then total number of documents divided by the number of documents with term T in it. This is the inverse document frequency. For example, if you have 10 documents, see, you have the total number of documents with you is 10. This is 10. Number of documents with term T in it will be, you can see, let us assume, more easier way. I will, then it would be more. See, let's assume that we have 1000 documents. The number of documents with term T in it is, we have only 10. So you will take logarithm of 1000 divided by 10. Logarithm of 1000 divided by 10. See, what is logarithm of 1000 by 10? That is log of 1000 by 10 is 100. Right? What is logarithm of 100? It is 2. So 2 is the, you can take it as the inverse document frequency. Inverse document frequency is how unique or rare the word is. So that's all about, the concept behind the TF-IDF algorithm. The implementation part, we will be covering in the next video. In this video, we discussed about the concept behind the TF-IDF algorithm, how we can implement using NLTK, that we will be, discussing in the next video. Thanks for watching. Please like, share and subscribe. Thanks a lot.